The first theorem of circle geometry states that a line that is drawn from the center of a circle to a chord, let's say the chord is AB, which is not a diameter, is perpendicular to the chord and also bisects the chord. Now take note of those 2 points. It says a line that is drawn from the center of a circle O to a chord AB, which is not at the diameter of the circle, is perpendicular to the chord and also bisects the chord. Those are the 2 points we want to get from theorem 1 of circle geometry. Hello, welcome to our class for today. In our tutorial today, we are going to analyze this first theorem of the circle geometry, and we are going to use 3 sample questions to help you understand and consolidate this theorem, so that whenever you see questions related to this theorem, you can easily face them and solve them with ease. If you are new to this channel, don't forget to hit the subscribe button and also hit the bell icon so that you can get notified whenever we upload our video content. Now, from the analysis I gave to you, we define the first theorem of the circle theorem as a line that is drawn from the center of a circle to a chord, which is not a diameter. They said is perpendicular to the chord and is also bisects the chord. Now, what does this mean? This means that if a line drawn from the center, from one circumference of a circle to another point of the circle, is not a diameter, so long as it bisects a chord, so long as it's not a diameter, it is perpendicular to that chord and it also bisects the chord. So that means if this chord is not at the diameter, or the line is not drawn from the center of the circle, then this theorem stands. Now, when we look at this theorem properly, you come to see that from the center of this theorem to this part of this chord, from the center of this theorem to this part of this chord, we have the radius, and that forms the radius. So if we take this point where the line bisects the chord, we take it at B, we have come to what? We have come to analyze this theorem. Now let's analyze this theorem properly. That is a chord AB, and at a point AB, we have come to see that we have 2 points. And this point, because this chord, this line bisects this chord into 2 equal parts, that means this part is equal to what? To this part. So that means we can simply say AP is equal to PP. That's the 1 point you should get to note. And you should also note that angle OPB is also equal to angle OPA. Both of them is equal to 90 degree. That's the point you should note. 2 things you must note: that this chord is this line is perpendicular to the chord, and they also bisect the chord into 2 equal parts. In solving this question, all you need to do is to bear in mind 2 things: that you are going to use the Pythagoras theorem. Now let's bring out one of these triangle. If we bring out one of these triangle, we're going to analyze one of these triangle. It's going to give us a right angle triangle. Now if it gives us a right angle triangle, we'll have here to be R, and this place, we'll assume this place to be X, which is the line from the center of the circle, and we'll assume here to be what? Y. Now if we use our Pythagoras theorem, remember Pythagoras theorem states that the hypotenuse, the square of the hypotenuse, is equal to the sum of the square of the other two sides. So we can now see from our Pythagoras theorem that r square is equal to x square plus what? Y what? Square. This is exactly what you use in solving questions related to this. Or we can say OB square is equal to OP square plus what? Plus PB what? Squared. That is exactly what you use whenever you are giving question related to this in the first theorem of Circle Theorem. Now, as you solve question on this, remember three key things. You'll be asked to find the radius of the circle, 1, which is this. 2, you will be asked to find the distance of the chord from the center of the circle, which is this. Distance of the chord from the center of the circle. And finally, you will be asked to find the length of the chord. So in any question you are solving under the first theorem of circle geometry or circle theorem, make sure that you are looking for these three things. If one is given, the other two will not be given, and if the other two is given, one will not be given. The questions are always tactical. Now let's go ahead to look at the first example that we are going to take. Now the first example says the radius of a circle is 10 centimeter. The length of a chord of the circle is 16 centimeter. Calculate the distance of the chord from the center of the circle. Calculate the distance of the chord from the center of the circle. So let's solve that question. We're going to analyze that question and then we'll now solve it. To analyze that question, remember the question says the radius of a circle is 10 centimeter. Now we are going to look at the point. We have our radius to be equal to 10 centimeter. Now, having gotten that radius, they now told you that the length of a chord of the circle is 16 centimeters. So this is the chord of a circle. We take the chord to be chord AB, and this chord is what? 16 centimeters. And we are told that the radius, which is this, is what? 10 centimeters. This is the center of the chord. Now they now told us to calculate the distance of the chord from the center of the circle. This is the part they want you to calculate. So having drawn that, all you need to do is to note that this line from the center bisects this line. So that means this line, if this is y and this is z, our z will be equal to 16 divided by 2, which is equal to 8 what? Centimeter. So we've gotten a point now. So we are going to use the Pythagoras theorem in solving this question. Remember, you are given this, you are given r, you are given the length of the chord, which is now 8 centimeter, and then which is 16 centimeter, and you are asked to look for the distance of the chord from the center of the circle. Now, once you are given any question like this, analyze the question, look at the parameters you are given and the parameter you are requested to look for, and then you solve your question. Now, let's bring out this. We'll bring out this small diagram out. We will now have this to be A. Let's take this to be B and this to be C. We have this as 10 centimeter. We now have this as 8 centimeter. We are looking for this, and this is a right angle. So this is the angle. This remains our hypotenuse, and this is the opposite, and this is the what? Adjacent. Now remember the Pythagoras theorem. It says the hypotenuse of any right angle triangle, it only works for right angle triangles, is equal equal to the square of the hypotenuse is equal to the sum of the square of the other two sides. So if we have that, we are going to have these solutions to become a square ac square equal to ab square plus bc square. So our AC is equal to 10 square equal to our AB is equal to x square plus what? Our BC is equal to 8 what? 8 square, all in centimeter. So this will give us 100 equal to x square plus 8 square is going to give us 60 what? Is going to give us 64. So we'll have our 64. So we'll make our x subject of formula. When this comes here, this will give us x squared equal to 100 minus 64. 100 minus 64, our x squared will be equal to 100 minus 64 will give us 36, right? That will give us 36. So we'll have our what? 36. So to clear this square, we are going to square root both sides. So we have our x squared equal to what? 36. Square root of 36. So if this cuts this, our x will now be equal to square root of 36 is going to give us what? Our x will be equal to square root of 36 is going to give us the value 6 centimeter. So you see that the distance from the center of the circle to the chord is what? The distance of the chord from the center of the circle is 6 what? Centimeter. You see how easy it is to solve this question. Now I want to give you the second question. As I read out this question, I want you to pause this video a little and look for a way of solving this question. Now the second question says the distance of a chord of a circle of radius 5 centimeter from the center of the chord is 4 centimeter. Calculate the length of the chord. Now let's analyze that question and then we'll definitely solve that question. Let's analyze the question. The question says we'll have a chord of a circle AB. The question says that the distance of the chord of a circle of radius 5 centimeter. The radius is what? The radius is 5 centimeter. The distance of a chord of a circle of radius 5 centimeter from the center of the circle is 4 centimeter. Now take note of that. This is 4 centimeter. This is the center of the circle. You are asked to what? To calculate the length of the chord, which is this full what? This full length. So you see, you are given the radius this time around, R, as 5 centimeter. You are given the distance from the center of the distance of the chord from the center of the circle, D, to be equal to 4 centimeter, and you are asked to calculate the length of the chord. Now the length of the chord, remember, is the full length from here to what? Here. Now let's assume that point to be P. We don't know what this side is, so we are going to bring out that small side. Remember I said pause this video a little and try this question before watching the solution. Now let's solve. We have this as 5 centimeter and we have this as 4 centimeter. We are looking for what? Y. Now remember that the length of the chord is not just the length of this side but the both length of the two sides. So we are going to find this very length first. Remember your circle, your Pythagoras theorem. The square of the hypotenuse is equal to the sum of the square of the other two sides. So we'll have our OP square equal to OP square plus our BB what? Square. So this will give us 5 square equal to 4 square plus y what square. While this gives us 25, this will give us what? 16 plus what? Plus y square. Now take note, this will come over here to give us 25 minus 16 equal to y what square. 25 minus 15 is going to give us 9, so that will give us equal to y square, and then our y will be equal to, if we square root both sides, it will be equal to square root of 9, while y is equal to what? 3. So you see now we've gotten our y to be equal to 3. Remember, the chord AB is equal to what? Is equal to AP plus what? PB. So we are going to have our AP or our PA to be equal to 2 times what? 3. So that means the length of the chord is going to be what? 6 what? 6 centimeter times 2. So you see that it's very easy solving question that has to do with the first theorem of question like this. You like this video? This is all I have for you for today. In our subsequent video, we are going to consider theorem 2. Don't miss that video. Hit the subscribe button so that you can be informed or alerted when that video is uploaded. Thanks so much for watching, and I look forward to seeing you watch our subsequent videos.